I want to talk about one of the most extreme volcanic eruptions in recorded history. It happened in April of the year 1815 on the Indonesian island of Sumbawa, then part of the Dutch East Indies. This eruption was so powerful, so violent and so devastating that it warrants talking about. It was an eruption so loud it was heard at least over 1400 kilometers away in the Moluccas. It was so explosive that it dwarfs most other eruptions you know about, and it ejected so much debris into the atmosphere that it literally caused a volcanic winter in the following year. In the 210 years since, the Earth has not seen another eruption at this scale. Mount Tambora is located on the Sanggar Peninsula on the north side of the island of Sumbawa and is part of the so-called Ring of Fire, a 40,000 kilometer long belt of volcanic activity that surrounds the Pacific Ocean, running from New Zealand through Indonesia, across Japan into the Aleutian Islands, down the west coast of North America, into the Andes, all the way down to Patagonia. It consists of thousands of volcanoes, involving many active tectonic boundaries. Tambora itself sits on the Sunda Plate, an independent plate forming part of the complex plate boundary between the Eurasian and Australian plates. It is one of the fastest subduction zones in the world, happening at approximately 7.8 centimeters per year. As the Australian plate subducts underneath the Eurasian plate, it has fractured part of the Eurasian plate and trapped various microplates, such as the Timor Plate, Banda Plate, Molucca Plate, and others, with the Sunda Plate forming the largest of these to the west. As the Australian plate subducts underneath it, it creates the Sunda Trench running off the south coast of Java and the Sunda Arc, a series of volcanoes running from Sumatra to Timor. The Sunda Arc is one of the most notorious volcanic arcs in the world, home to earlier devastating eruptions such as the 70,000 BC Toba eruption, the 1253 AD Salamis eruption, and the 1883 Krakatoa eruption. It is in this context we should examine what happened at Tambora in 1815. Tambora is a typical stratovolcano in the Sunda Arc, which prior to its 1815 eruption had been quiet for possibly millennia. While no direct records exist, using radioactive carbon dating, it's estimated Mount Tambora formed roughly 50,000 years ago, an event which drained a large magma chamber pre-existing under the mountain, with later eruptions possibly happening in 3910 BC, 3050 BC, and 740 AD, though these are not recorded and have some uncertainty in their exact dates. Nevertheless, it can be reasonably assumed Mount Tambora had been mostly dormant for the better part of a millennium by 1815. During this period of dormancy, the volcano's underlying magma chamber slowly refilled. Tambora's magma chamber is located between 1.5 and 4.5 kilometers below the mountain, a depth not particularly unusual for stratovolcanoes like Tambora. What eventually triggers an eruption is that the magma in such a chamber is less dense than the surrounding rock. Hence, it's gradually pushed upwards through the effects of buoyancy. As this happens, it will often trigger an increase in elevation at the mountain. By the late 18th century, Tambora's summit reached roughly 4,300 meters above sea level, making it one of the tallest peaks in the region. At the start of the 19th century, Sumbawa was controlled by various petty kingdoms, with the area around Mount Tambora itself being controlled by the aptly named Kingdom of Tambora, which by 1815 may or may not have been part of the Sultanate of Bima, itself nominally a Dutch vassal by 1815. Regardless of its exact political status though, Tambora was a well-off trading kingdom, home to about 10,000 people or so. The Tambora people's language was unique, and not one of Austronesian origin, possibly a language isolated or related to the Papuan languages further east. Only one word list was collected before the eruption from it, from which we can only definitively say it wasn't Austronesian. Apart from the Tambora kingdom though, the island also had other principalities or petty sultanates including Sumbawa, Bima, Dompo, Sanggar and Pekat. These states were mostly located near rivers and teak forests. The people of Sumbawa were known for their horses and many natural resources such as the valuable sappanwood, coffee, pepper and rice, with the island being agriculturally productive as many lands surrounding volcanoes often are. And so, the island was part of an extensive trading route across maritime Asia. By the early 19th century, the mountain peak had risen to a height of 4,300 meters above sea level. Its estimated temperatures inside the magma chamber exceeded 800 degrees Celsius at this point. Since Tambora's chamber is estimated to be relatively shallow, this heat generated a lot of pressure, and its estimated pressure inside the chamber might have reached up to 4,000 to 5,000 bars of pressure. This is an enormous number, and more than 5 times the pressure found at the bottom of Mariana's Trench. All these factors combined meant an enormous eruption was slowly building up beneath the volcano. In 1812, 3 years prior to what would be the main eruption, Tambora woke up from its 1,000-year slumber. After centuries of building up heat and pressure, the mountain finally began to rumble and dark clouds started to rise from its caldera. For now though, these were only accompanied by small tremors and steam emissions. Records from this period remain sparse, with these early eruptions being confirmed mostly by excavated ash layers rather than direct witness accounts. With modern volcanology still absent at the time, it's unlikely the people inhabiting the area around the volcano understood what was happening. The rumbling and steam eruptions which started in 1812 would continue for 3 years, all the way up to 1815. It may seem surprising that we have no direct records of these, given there would have been, well, a giant smoking volcano next to what at the time was a flourishing trading kingdom. And while the native records would have obviously been destroyed in the eruption, no records by traders visiting the island survive either, which reflects just how remote the island of Sumbawa was at the time, sitting on the very edge of the explored world, with colonial rule there being more of a de jure rather than a de facto situation. By April 1815, the volcano had been rumbling and spewing steam clouds for the better part of 3 years. It must have almost become a normal part of daily life on the island by this point. But underground, the situation had become critical. Over the centuries of dormancy, the magma inside the vent connecting the chamber to the caldera had cooled and crystallized. This less viscous magma had up to now been blocking the volcanic vent, which would otherwise allow the pressure to escape through an eruption. Until then, this vent remained sealed, but in the morning of 5 April 1815, it could simply no longer contain the immense pressure inside the magma chamber, and it finally caved. Overpressurization of the chamber was reached, and the sealed vent was suddenly and violently ruptured with a force of at least 5,000 bars. We only know the pressure went at least that high due to later analysis of the ejected lava. When the vent ruptured, the underlying high-pressure magma and volcanic gases burst up through the vent with such violence it generated a powerful shockwave in the atmosphere, sometimes described as a sound. While volcanic eruptions being extremely loud is not particularly unusual, it is inaccurate to describe these blasts as sounds. While both sound waves and shock waves are pressure waves in the atmosphere, they differ significantly in intensity and speed. A normal sound wave is limited by the speed of sound, and does not disturb the air much when traveling through it. Sound thus has a theoretical loudness limit in the Earth's atmosphere of roughly 194 decibels. That's incredibly loud, hundreds of times louder than a rocket launch 1 meter away, and as such sound waves rarely reach this level of loudness. Shock waves, on the other hand, travel at supersonic speeds and cause an abrupt and violent change in the air as they pass through. Try to imagine it as the difference between a gentle ripple in a pond and the splash of someone dropping an anvil into the water. The shockwave created at Mount Tambora on the 5th of April 1815 is estimated to have been so powerful it could have measured over 300 decibels at sight. This is an almost incomprehensible number, over 1 trillion times the sound limit in Earth's atmosphere. The shockwave generated would have been powerful enough to rupture eardrums dozens of kilometers away from the eruption, generating a pressure wake that would travel hundreds of kilometers. Tambora would go on to not just produce one, but many of such powerful shockwaves. Witnesses describe a rumbling that would continue into the evening and days beyond. But how was Tambora able to do this? The eruption involved repeated vent ruptures and explosive releases of pressure. Even though the vent was initially blasted open on April the 5th, the magma reservoir underneath remained highly pressurized. And it doesn't simply vent 5,000 bars of pressure in a single blast. So the subsequent blasts were powered by the continuous infusion of magma rising from deeper reservoirs, gas exhaustion, and fracturing of rock, which kept producing massive blasts throughout the following days. In the city of Makassar, about 380 kilometers northeast of Tambora, a British East India Company vessel reported hearing sounds like firing of cannon throughout the afternoon and night, initially mistaking the noises for an attack by pirates. Further away, at 1,200 kilometers in Batavia, Sir Stamford Raffles, then governor of the British-occupied East Indies, wrote the following account of the noise. The first explosions were heard on this island in the evening of 5 April, and they were noticed in every quarter and continued at intervals until the following day. The noise was, in the first instance, almost universally attributed to distant cannon. So much so that a detachment of troops was marched from Yogyakarta in belief that a neighboring post was being attacked. And along with the coast, boats were in 2 instances dispatched in a quest of a supposed ship in distress. The sound was also recorded in Ternate in the Moluccan Islands over 1,400 kilometers east of Tambora, where authorities sent naval vessels to investigate after once again assuming the sound to be cannon fire. Additional accounts suggest that the eruption sounds may have reached even further, to Sumatra, 2,600 kilometers away, and new analyses indicate that faint rumbles could have been heard even further, in Thailand and Laos, which if true would have been over 3,300 kilometers away from the eruption site, a truly staggering distance. The initial eruption on 5 April 1815 would go down as one of the loudest recorded noises in human history up to that point, matched only by other infamous volcanic blasts such as the Krakatoa later that same century. And while initially mistaken for cannon fire by most, the true scale of what was happening would soon become apparent. With this powerful blast, the eruption had officially begun, and the Tambora now entered the start of a particularly long and dramatic eruption period that would end up lasting just over 3 months. Not unheard of, but remarkably long for a stratovolcano of this type. All the while, it would be bellowing out ash clouds that could have reached 30 to 40 kilometers up into the stratosphere. The next day, on the morning of 6 April 1815, ash began to snow down in Surabaya and eastern Java, confirming beyond a doubt to anyone that this was indeed a volcanic eruption and not mere cannon fire as many had previously suspected. Some sources claim the local people initially went to collect the ash, believing it to have strange medicinal properties. But over the next few days, the ashfall became thicker and more sustained, spreading further westwards and obscuring the sunlight as the atmosphere filled with a thick yellow haze, and making even high noon appear pitch black. All the while, the distant rumbling of explosions could be heard in the background. Sir Raffles provides us with another account. On Java, at the distance of 500 kilometers, it seemed to be awfully present. The sky was overcast at noonday with clouds of ashes. The sun was enveloped in an atmosphere whose palpable density he was unable to penetrate. Showers of ashes covered the houses, the streets, and the fields to the depths of several inches. And amidst this darkness, explosions were heard at intervals, like the report of artillery or the noise of distant thunder. These accounts sketch a truly horrific view of the eruption even at 500 kilometers distant. Due to the monsoon winds typical of April in the region, most of the ejected ashes had blown disproportionately westward, affecting Bali and Java the most, while the situation east of Sumbawa on the islands of Flores and Timor would have been noticeably less severe. Sadly, however, no Portuguese records regarding the eruption survived, which reflects just how much on the edge of the explored world Sumbawa still was at that time. On the morning of the 10th of April 1815, the situation near the volcano was already a complete disaster show. On Java, the days were dark and the sun had not been able to penetrate the volcanic haze for almost a week. The island of Bali was covered in a knee-deep layer of ash, and the once prosperous kingdom of Tambora, situated right on the foot of the mountain, would by that point likely already have been utterly devastated. Despite that, around 7 PM in the evening of that day, Tambora's eruption would enter its Plinean stage. The Plinean stage of an eruption is the most violent and devastating part. Plinean eruptions are modeled off the eruption of Mount Vesuvius in 79 AD, which infamously destroyed the Roman towns of Pompeii and Herculaneum. They are characterized by their sustained explosive activity, during which they eject massive amounts of volcanic debris into the atmosphere. Typically, these are short, violent events lasting between a couple of hours to a day or so, and that night, Mount Tambora would create a true horror show. At around 7 PM that day, the mountain ejected at least 3 separate columns of ash and debris, which merged at great height, creating a massive and turbulent eruption column towering 40 kilometers high into the atmosphere. Within an hour thereafter, pumice started raining down on the island, some pieces 20 centimeters wide. By 9 PM that evening, the ashfall started to intensify, completely burying some villages. The Raja of Sengar, who was an eyewitness to these events, gives the following account. At about 7 PM, 3 distinct columns of flame burst forth near the top of the Tambora mountain, all of them apparently within the verge of the crater, and thereafter ascending separately to very great height, their tops uniting in the air in a troubled, confused manner. In a short time, the whole mountain next to Sangar appeared like a body of liquid fire, extending itself in every direction. The fire and columns of flame continued to rage with unabated fury until the darkness caused by the quantity of falling matter obscured it at about 8 PM. Stones at this time fell very thickly at Sangar, some of them as large as 2 fists, but generally not larger than walnuts. Between 8 and 10 PM, ashes began to fall. And soon after, a violent whirlwind ensued, which blew down nearly every house in the village of Sangar, carrying the tops or roofs and light parts away with it. The violent whirlwind the Raja is describing here was most likely a pyroclastic flow event. Pyroclastic flows are fast-moving avalanches of hot ash, gas, and other volcanic debris that rush down the slopes of a volcano during eruptions. At around 10 PM that evening, the eruption column of Mount Tambora collapsed, creating not one, but several violent pyroclastic flows, ravaging the surrounding landscape. Whatever was left of the trading kingdom of Tambora by this point was completely wiped off the face of the earth, its remnants buried and its people carbonized, the unique, poorly attested language of the Tambora civilization having died with them. Later archaeological excavations have uncovered charred houses buried beneath meters of hot volcanic deposits, with human skeletons still found inside. Meanwhile, the town of Sangar was located on the eastern slope of the volcano and saw similar levels of destruction. When the pyroclastic flows hit the water of the bay, it generated a moderate tsunami, that in the bay itself rose to be about 4 meters high. An account of the tsunami hitting Sunamap, about 300 kilometers distant of the eruption, describes the following. On the evening of the 10th, the explosions became very loud. One in particular shook the town, and they were excessively quick, resembling a heavy cannonade. Towards evening next day, the atmosphere thickened so much that by 4 o'clock it was necessary to light candles. At about 7 PM of the 11th, the tide being about ebb, a rush of water from the bay occasioned the river to rise 4 feet, and it subsided again in about 4 minutes. The bay was much agitated about this time, and it was illuminated from a northerly direction. On the island of Hovatoff, fire was seen distinctly at a short distance to the southeast. The uncommon darkness of this night did not break till 10 and 11 AM of the 12th, and it could hardly be called daylight at all. Volcanic ash fell in abundance and covered the earth about 2 inches thick. The trees were also loaded with them. Though the peak of the eruption was reached on the 10th that day, the volcano would continue to rumble and only gradually started to calm down over the following weeks and months with decreasing intensity, for the most part quieting down by mid-July 1815, though a noteworthy aftershock of the eruption occurred in 1819. Ships attempting to reach the Tambora area in mid-April reported floating mats of pumice ice covering the waters and could not get close easily. As such, relief efforts were significantly delayed. Nearly all vegetation on Sumbawa had been destroyed, and the entire geography of the Sangir Peninsula had been altered, with the mountain summit especially having been greatly reduced. At least 10,000 deaths could be attributed to the eruption directly, a number which would rise above 100,000 the following year. The Volcanic Explosivity Index is a measurement of scale for eruptions, measuring how much debris was ejected. It runs logarithmically from 0 to 8, with high-end eruptions being very rare. VI 5 eruptions emit over a cubic kilometer of debris and are somewhat common, happening maybe every decade or so. A VI 6 eruption is more rare, happening once or twice a century and emitting over 10 cubic kilometers of debris. Tambora's 1815 eruption comfortably ranks as a VI 7 eruption and is estimated to have released up to 175 cubic kilometers of debris into the atmosphere. For comparison, this amount of debris is roughly equivalent to the volume of water in massive lakes, such as Lake Vänern in Sweden or Lake Athabasca in Canada. And much of that ejected debris stayed in the atmosphere in the form of sulfate aerosols, creating a haze effect, blocking sunlight. This effect was then further amplified by the fact that a few years earlier there had been another big volcanic eruption further east, so the atmosphere was already filled with a large amount of volcanic emissions. So that in the following year, 1816, a gross yellow haze circulated the world, causing temperatures to drop, by some estimates up to a whole degree that year. The year 1816 would be best described as a volcanic winter and would go down in history as the year without a summer. Third US President Thomas Jefferson was an enthusiastic amateur meteorologist and provides a detailed account of that year's unusual weather phenomena. The spring has been unusually dry and cold. Our average morning cold for the month of May in other years has been 70 degrees Celsius. In the present month, it has been to this day an average of 12 degrees, and one morning as low as 6 degrees. Repeated frosts have killed the early fruits, and the crops of tobacco and wheat will be poor. He continues, "We have had the most extraordinary year of drought and cold ever known in the history of America. In June, instead of 95 millimeters, our average of rain for that month, we had only 8.5 millimeters. In August, instead of 232 millimeters, our average, we have had only 20 millimeters, and it still continues. The summer too has been as cold as a moderate winter. In every state north of this, there has been frost in every month of the year. In this state, we have had none in June and July, but those of August killed much corn over the mountains. The crop of corn through the Atlantic states will probably be less than a third of an ordinary one. That of tobacco still less, and of mean quality. Indeed, the weather deviations that year would result in massive crop failures all across the world, not just in the US, but also in Europe, China, and elsewhere. Though few at the time, and not even Jefferson, would be able to connect the dots to Tambora, the climate anomaly caused by the eruption resulted in more famine and additional tens of thousands of deaths. With these factored in, the final death toll of the eruption could have reached millions. But the gloomy, hazy atmosphere that year would also leave a lasting cultural impact. First and foremost, through the demise of the Tambora culture, its unique language lost and only poorly attested. But the strange atmospheric scenes of the year without a summer would also go on to inspire many painters, such as William Turner and Caspar Friedrich. In China, the ensuing cold and famine triggered a revival in traditional poetry, and most famous of all, the grim weather would inspire horror classics such as The Vampire and Frankenstein. Without a doubt, the eruption of Mount Tambora in 1815 was a world-changing event, and even though it happened on the verges of the explored world, its effects should not be understated, and reached from total destruction on Sumbawa to famine all across the globe to a year without a summer. Eruptions at this scale tend to be rare events, happening maybe around once every 500 years or so. In the 210 years since the Tambora eruption, the world has not witnessed another eruption at this scale. For now. So I hope you found this video informative. Leave a like and a comment if you did. I usually don't do volcano videos like these, but the Tambora rabbit hole had enticed me, so here we are. I tried writing this video like a documentary of sorts, which is a direction I've been trying to pursue with my videos for a while now, so if that's something you'll like, stick around and subscribe. And as always, thank you so much for watching, and I'll see you guys in the next one. Later!